We're still graphing just like we were before, except it's an inequality instead of an equation. So first it says to graph y equals x plus 1 on the coordinate plane. What is the first point we are going to put down? 1. 1. The y-intercept, so remember y equals mx plus b, where b is the y-intercept, which is your starting point. M is the slope, which tells you how much to rise and how much to run. Everything you need is right there. So y equals mx plus b. That means that the b, or the y-intercept, is 1. The slope, m, is what? 1 over 1. There's nothing there, so in front of x is a 1. When there's nothing in front of the x, it's a 1. So we go up 1 over 1. And then just like before, we go ahead and connect those 2 points. Stop talking. All right, now change the equal sign to a greater than or equal to sign. So y is now greater than or equal to y is greater than or equal to x plus 1. We're using the same equation from number 1, and we're turning it into an inequality. And then it says to choose 3 points from the graph that lie above the line. Substitute each one into the inequality and check if it makes a true statement. So we can pick any 3 points from above the line. So let's pick this one. That's negative 1, 1. We have this one right here, which is 2, 4. That's not right. Yeah, it is. 2, 4. And then let's also do negative 5, 0. So those are all 3 points that are above the line. Now we're going to plug them into the inequality. So y is greater than or equal to x plus 1. So what is the y that I'm plugging in? 1 is y. So 1 is greater than or equal to negative 1 is the x. So negative 1 plus 1. And then simplify. So 1 is greater than or equal to 0. Is that true? Yes, y is bigger than 0. So that is true. Just going to put a little check mark for right now. Let's try again with 2, 4. So y is greater than or equal to x plus 1. So y, we're going to plug in 4. 4 is greater than or equal to 2 plus 1. So 4 is greater than or equal to 3. Yes, that is also true. So I'm just going to put a little check mark. Then y is greater than or equal to x plus 1. So plug in 0 for y. Negative 5 for x. So negative 5 plus 1 is negative 4. Is 0 bigger than negative 4?
Yes.
Yes. So all 3 points were true. Now let's try the opposite direction. Let's pick 3 points from below the line. So let's say 0, 0 is below the line. This point is 3, 2. And then let's do negative 1, negative 3. So again, we just plug that in to the original inequality. Y is greater than or equal to x plus 1. So 0 is greater than or equal to 0 plus 1. 0 is greater than or equal to 1. Is that true?
No.
No, so let's just put a little x. Y is greater than or equal to x plus 1. Plug in the 2 for y. So 2 is greater than or equal to 3 plus 1. 2 is greater than or equal to 4. Is that true?
No.
No. Plug in negative 3 for y. Negative 3 is greater than or equal to negative 1 plus 1. So negative 3 is greater than or equal to 0. Is that true?
No.
Sorry, I put my sign the wrong way. No, that's not true. So it says shade the side of the line that contains all of the points that will make it true. So which side is true? The top. All the points we plugged in from above were true. So we're going to shade that whole part of the graph. What if the inequality symbol was reversed? What do you think you would shade then?
The bottom.
Right. So if it was reversed, you would shade the bottom. All right, on the next page. So just like when we graph inequalities on the number line, remember that if it's equal to, it's a what kind of dot? Shaded in dot or shaded in circle. And what if it's not equal to? It's open. So just the same, if we are graphing less than and greater than without an equal sign, you are going to use a dashed line. And if it is less than or equal to or greater than or equal to, you are going to use a solid line. So for example, y is less than x plus 2. There is no equal to. What's the first point that I plot? 2. What's my slope? 1. So up 1 over 1. It does not have an equal to sign, so I'm just going to make this a dashed line or dotted line. And we're going to talk more about the shading in just a second. Which side do you think we shade? It's a less than, so we're going to shade the bottom. All right, then the next one is the same thing. They just replace the less than sign with less than or equal to. So your intercept is still a positive 2. Your slope is still up 1 over 1. What's the only difference between these two graphs? It's a equal sign, so it has a solid line.
What's the difference between a solid and a dash? They look the same.
This doesn't have an equal to, and this one does.
No, like by how it looks.
This is dash. It's like just you kind of skip
Got
space.
Okay.
All right, so now we're going to put this all together. Step 1, you are going to plot the y-intercept and slope, just like normal. So what is the y-intercept here? 3. So our first point is positive 3. And then what is our slope? Up 2 over 1. It was a positive 2 slope. All right, and then is it a solid or a dashed line? Dashed. So connect with a dashed line. No. So we connect those two with a dashed line. And then you test a point and shade. I always use 0, 0 because that's always an easy point to solve with. So I always choose 0, 0 as my test point. So y is less than 2x plus 3. So 0 is less than 2 times 0 plus 3. So 0 is less than 3. Is that true?
Yeah. But wait.
Yes.
Can't you just look at the greater than or less than?
But that's not always going to work out that way. So you need a backup plan.
Okay.
Okay. All right. So since it is true, I shade the side that has 0, 0 on it. And Ahmed asked if I couldn't just look at the sign and tell it's less than, so I need to shade below. And that is true. But we're about to see some more complicated ones where that won't work. So it works for these, but it's not going to work for every one. All right, try the understanding. All right, for the first one, what is the intercept? -1. And what is the slope? 3. Up 3 over 1. And is that a solid or dashed line? Solid. And which side did you shade?
Top left, top right.
The top left, so whatever side you want to call that. So if you're not sure about looking at it, plug in 0, 0. So 0 is greater than or equal to 3 times 0 minus 1. So 0 is greater than negative 1, which is true. So we shade the side that has 0, 0, which was this side.
Oh, that's how the stuff is on mine.
All right. B. What is the y-intercept? 3. What is the slope? Negative 2. So I go where? Down 2 over 1 to the right.
You still go to the right.
It's always to the right.
Unless it's a negative.
The negative tells you to go up or down. The negative tells you to go down. Positive tells you to go up, and it's always to the right. So, is it a solid or dashed? Dashed. Which side did you shade? The top or right side. So if you were not sure, again, plug in 0, 0. So 0 is greater than negative 2 times 0 plus 3. So 0 is greater than 3, which is not true. So I cannot shade the side that has 0, 0 on it. I have to shade the opposite side. C, what is the intercept? And what is the slope? 1. Up 1 over 1. Is that solid or dashed? Dashed. And which side of that one did you shade? The bottom side, because it's a less than. Or if you weren't sure, plug in 0, 0. 0 is less than 0 minus 4. So 0 is less than negative 4, which is false. So I cannot shade the side that has 0, 0. I have to shade the other side. So the shortcut, which we just talked about, was that if y is greater than, we are going to shade what side? The top. We are going to shade above the line. And if y is less than, then you shade below the line.
Does it work for equal to as well?
Well, we don't shade when, yeah, like less than or equal to?
Yeah.
And this only works when it's in y equals mx plus b form, slope-intercept form, is the only time this little shortcut works. So when you turn the page and you're in standard form, it's not going to work in standard form. So in standard form, we're going to do the same thing we did to graph the lines when it was in an equation. We are going to find the intercepts using the cover-up method. So that's step 1. Find the intercepts using the cover-up method. So first, let's cover up x. And what is y?
Negative 3.
Negative 3. And then let's cover up y. And what is x? 5. So our two intercepts, we have 0, negative 3. And we have 5, 0. And is that going to be a solid or dashed line?
Solid.
It is an equal to, so it will be a solid line. So we are going to draw a solid line. And then we are going to test a point and shade it. Again, the easy point to choose here is 0, 0. So 0, 0 is right in the middle. 3 times 0 minus 5 times 0 is less than or equal to 15. So 0 minus 0 is less than or equal to 15, which is 0 is less than or equal to 15. Is that true?
Well,
Everyone should be able to answer that question. Is 0 smaller than 15?
Yes.
yeah.
Is 0 Smaller than 15. Yes. So 0 is smaller than 15. So that is true. So I can shade the side that had my test point, 0, 0. So I shade that side of the equation. So notice we cannot use the inequality sign to determine if I shade above or below. You have to actually figure it out. It says, or you can solve for y, get it into slope-intercept form yourself. But there's an issue with doing this, and let's look at what the issue is. So if you'd rather do this method, you can. What would be the first step in getting y by itself? Subtract 3x from both sides. So negative 5y is less than or equal to 15 minus 3x. And then what do? Divide by what? Divide by negative 5. When I divide by a negative, what happens to my inequality sign? It flips. So now I have y is greater than or equal to negative 3 plus 3/5 x. Or rearrange it so y is greater than or equal to 3/5 x minus 3. So you can either do the cover-up method and use the intercepts and graph it and use a test point, or you can set it equal to slope-intercept form, y equals mx plus b, plot your intercept and slope, and you know that you had to shade above the line because it's a greater than. So pick one of those two methods and do the understanding check below. A, what was the y-intercept? The y-intercept. So covering up the x, it would be 3. What is the x-intercept? 4. And was that a solid or dashed line? Dashed. And if you plug in the test point 0, 0, or whatever test point you may choose, so 0 would be plus 0 is greater than 24. Is 0 greater than 24? No. So you cannot shade 0, 0. You have to shade the opposite side. You understand why?
No.
So if you plug in 0, 0, you get that 0 is bigger than 24, which is not true. So that means this is not a true point. That can't be shaded because 0, 0 is not right.
I just wrote my sign.
All right. Part B. What is the y-intercept? The y-intercept. Negative 2. What is the x-intercept? 5 over 2, which is 2.5. Is that solid or dashed? Solid. And test the point 0, 0. So 0 minus 0 is greater than 10. Is 0 greater than or equal to 10? No. So again, I cannot shade the side with 0, 0. So I'm going to shade the opposite side.